All right, here we go. We're going to start graphing, which is what this standard is all about. It's to be able to graph and understand the nature of the graph and all the key features. So we will be looking for domain and range and intercepts, and these graphs also have asymptotes. So we will be looking at, now there'll only be one asymptote per graph, so that's important. And we're going to start with graphing exponential functions. The next video is going to be on graphing logarithmic functions. They are very similar because they are inverses of each other, so you can imagine the two graphs should reflect over the line y equals x. So they will look like mirror images, but one is going to have a horizontal asymptote and one is going to have a vertical asymptote. So that's going to be the key to remember which is which. So let's go ahead and get started. This is the basic shape of our exponential graph. Now, I've often used b as my base. It doesn't matter what variable we are using there, but we are going to use, we have a base to the power of x. So the base stays constant and it's the exponent that's changing. So in this case, we can see that the exponent must be making this larger. So I have, in this case, my domain is every single x value along here is going to get used. So my domain is all real numbers. But I do see that this thing is riding along the x-axis here. So my asymptote in the standard graph is going to be y equals 0, which is the x-axis. Okay. Now, my range means that I'm not going below the x-axis. There's nothing that's going to make this negative. It's never going to be negative because 0 it's not even going to be 0 ever. Which means my range is going to be from 0 to positive infinity, and that is exclusive. Keep that in mind. My y-intercept is whatever is going to, when I substitute in a 0 for the x, which is often going to be 1 unless I have some sort of transformation. So 0, 1, because when you put a 0 in, we get an outcome of 1 because 0 is my exponent. All right, so that's the basics. Now grab your calculators. So if you need to pause, grab your calculator and let's get started. So the first thing we're going to do is we're going to enter this in our calculator and take a look at the table of values. And I just want to write a couple down so that we can see what we're actually graphing. So go ahead and enter this in the calculator and take a look at the graph. The picture itself looks very similar to the one that was on the first screen of our video. So it looks very similar, but let's look at the table. So hit second table, and if you notice that, scroll up and down so you can see this, but your negative numbers become really, really small. And some even say like negative 5. So that's saying times 10 to the negative 5th power, times 10 to the negative 6th power. So this is taking a number and adding a bunch of zeros behind the decimal place. So those numbers are really, really small. So I would say the smallest one we could even attempt to plot might be negative 2, maybe. So negative 2 gives me 0.1 repeating. Negative 1 is 0.3 repeating, which would make sense because I'm taking 3 to the negative 1, which is 1/3. This 0.1 is actually 1/9. That's where the 0.1 repeating. And then 0 is 1. 1 is 3, that should make sense. 3 should be 9 because we're squaring it, and cube is squared, and then 3 should be 27 because we're cubing it. I can't graph all the way up to 27, but I do have quite a few values here that are acceptable to graph. So go ahead and plot those. So if you need to pause the video, do that because I'm going to do it really quickly. And then we'll come back and we will do the domain, the range, the asymptote, and our y-intercept. All right, there you go. Please notice I have arrows on both ends of my graph because this does go on infinitely towards positive infinity there. So my domain, once again, is all real numbers. I have no restrictions on what x's I can use. Some produce nicer numbers than others, but there's no restrictions. My range is limited by my asymptote, so maybe we'll write the asymptote as well. My asymptote is y equals 0. Even though these numbers got really small, none of them ever went below 0. I just kept putting more zeros in the decimal, like behind the decimal place, but it never went negative. And that makes my range from 0 to positive infinity. And the last thing is, what is my y-intercept? It has no x-intercept because it's never crossing the x-axis here. It never even touches it. But my y-intercept is 0, 1 in this case. All right, great job. We're going to try another. All right, for this one, we've applied some transformations. So these transformations work the same way they always have. If there's something with x, it's always the opposite direction, and it always moves it left or right. So in this case, we're moving to the left 2, and this is moving us down 1. So these are the same transformations that we saw with parabolas and we saw with absolute value. They're the same idea. So go ahead and enter this one into your y equals so we can take a look and see what it appears to have done on the graph. Alright, so when you look at the graph, you can definitely see that it did move to the left, and it's now below the x-axis, which is the downshift that this took. So once again, pull up in your table of values and take a look at what we get. And if you keep scrolling in the negative direction, you can see you get negative 0.9998, 9999, and then all of a sudden you get a negative 1. Well, you'd think that, well, maybe it equals negative 1. But if you actually move your cursor over into the y column of your table, you'll notice at the bottom of your screen that it doesn't actually equal 1. It's just ran out of places to put the 9s. So it's rounding because that's how wide the column is on your calculator. So it never actually gets to negative 1. It will continuously be 9999999, but it will never be negative 1. That tells us that's where our asymptote is. So before we get ahead of ourselves, let's go ahead and pick some values that we're able to put onto our graph. So for our x values, I think the smallest one maybe we can graph that's reasonable would be like a -4, -3, -2, -1 for sure, and 0, because once you get past 0, then 1 is 26. So these are the values that I'm going to plot. I think 5 is appropriate, -0.8889. Okay, so it's almost a -1. Then we have -0.6667. Okay, -2 gives me a 0, a 2, and an 8. And so these are a little bit less predictable, but there's still a pattern. I'm still using values. You see the 3 squared, -1. 3 to the first, -1. This would be 3 to the 0, -1. So these values are still related to a base of 3, but they've been shifted. All right, so let's go ahead and pause the video now so you can plot them. When you come back on, we can compare graphs. So pause now, please. All right, there's my graph. So let's take a look again. Our domain is all real numbers. There's no restrictions on what x can be. I can choose lots of values. My range, however, is dependent on my asymptote. So our asymptote now has moved down. And remember, we talked about how it got really close to -1, but it just was really -0.99999 forever. So my asymptote is at y equals -1. So that tells me that my range is exclusive from -1 to positive infinity. And lastly, I have a y-intercept, which came up in my table very nicely at 0, 8. This one does have an x-intercept, so we can note it. It is -2, 0. That one turned out pretty nice. All right, we're going to go on to the next one. All right, for this one, we have a base that's less than 1, so we're going to take a look and see what that does. So take a second, if you need to, pause the video, enter this in your calculator, and take a look at the graph and the table. Pause now. All right, so looking at your table, hopefully you've scrolled up and down a little bit, but you kind of see that the table is reversed. Like when you go in the negative directions, the numbers get really big, but when you go in the positive direction, the numbers start to get really small. So in this case, when we take a look at it, I might choose more positive numbers or less positive numbers and more negative numbers. So -3 produces 8, Okay, which doesn't surprise me. When you cube this, you get 8 and it flips it over. Negative 2 gives me 4. Negative 1 gives me 2. 0 gives me 1. 1 gives me 0.5. And maybe I'll just do one more. 2 gives me 0.25. So this really shows me that it really took the reciprocal and it flipped it over. Well, what does that look like on our graph? So take a second and you can plot these points and we'll come back and do all of the information. Pause now. All right, this is my graph. Looks like the one on my calculator screen. I've got enough points to show the nature of how it's decreasing as you move over to the right side. So this is a decreasing graph. My domain is still all real numbers. There's no restrictions. My asymptote is still going to be the x-axis, y equals 0. My range, therefore, is exclusive from 0 to positive infinity. And my y-intercept is 1. So kind of a very general graph of showing what it looks like when the graph is decreasing, and that has to do with the base being less than 1. I'm taking a fraction and I'm raising it to an exponent. The numbers are going to keep getting smaller if my exponent keeps getting bigger. All right, we're going to go ahead and move on. So here we've got this base of 1/2, but now I've thrown all these transformations on it. So here, again, this one moves in the opposite horizontal direction. So this is to the right 3, and this one went up 2. So we should notice that. So again, I want you to pause the video and to take a look at the table and the graph and then come back, because I want you to be able to have that done without me, and you can just confirm that you did it correctly when you see what I've got. So go ahead and pause now. Okay, so again, I saw that a lot of my negative values were negative x values, which would be my exponent, would produce these really, really big numbers that weren't going to fit on my graph. But as I got into the positives, the numbers got smaller and smaller and smaller. So let's gather our information. My domain is always all real numbers. There's not a single value I can't put in the exponent, positives or negatives or otherwise. Okay. My asymptote, however, this time is above the x-axis, and it's at 2. It's at y equals 2 is where my asymptote is. So nothing's going to go below my asymptote. And my range then would be from 2 to positive infinity. That's exclusive because it's never going to hit 2. It's going to get really, really close, but it'll never hit it. My y-intercept is at 0, 10. And I do not have an x-intercept because it's never going to cross the x-axis because it's never going below 2 in the first place. All right, we're going to keep going. So here's kind of a summary of what happens. So how do transformations affect our graph? So this horizontal transformation moves it left or right. This right here is our vertical transformation, moving it up or down. Well, that affects, the up or down affects two things. The up or down is going to affect my asymptote, and it's going to affect the range because my range is dependent on the asymptote. My up and down is going to position the asymptote. Again, that affects the range. So these are all very much connected. My y-intercept is going to be affected not only by the up or down, but also by the left or right, because that'll tell me when it's going to cross. So my y-intercept is really dependent, and I really just strongly believe in using the calculator or to plug in 0 for x. My domain is always all real numbers. It will never be affected by any transformation because there's not a single value I can't put in the exponent, positives and negatives, decimals, fractions, it doesn't matter. Growth or decay. The growth or decay, this is talking about increasing or decreasing. And our increasing graphs are always when the base is greater than 0. So my base can be 1.5 because that's greater than 1. Greater than 1. And that's going to be if I put a base like, my base could be 1.5, my base could be 2, my base could be 7. So whatever my base is, because that's going to make the value get bigger and bigger. We saw the decrease, we saw the decay, the values getting smaller when my base was between 0 and 1. Now I say between 0 and 1 because my base will never be negative. But I want to keep it less than 1. In other words, I want to keep it a fraction that's between 0 and 1. Okay, I don't want to just generally say fraction because the fraction could be 3/2, but 3/2 would be growth, but 1/2 would be decay. So that also affects the shape of my graph. All right, we've got to take a look at one more thing here. We're going to be talking about the graph of e to the power of x. So we're still going to talk about these four things, but go ahead and type into your calculator e to the power of x. So pause now, take a look. I want you to get a table and a graph before you join me again. Okay, so as you saw, because we have this base that is already a crazy looking number, 2.718 and so on, what happens is that none of our values except one nice one, the y-intercept, are going to be lovely to graph. But we have to pick a few. So I picked 4. I picked 1 in the negatives, I picked the y-intercept, and I picked 2 on the positive side of the y-axis. So there are values you can pick. You do have to approximate. And that's why I do expect to see a table so I know which values you were attempting to graph and how accurately you graph them. So my domain here is still all real numbers. Once again, no limitations on what I can use for an exponent. My asymptote is still the y-axis or x-axis because I did not have any shifts up and down. My range is from 0 to infinity based on my asymptote, and my y-intercept is 0, 1. So the information is very basic. What's complicated or ugly looking, perhaps, are the values that I actually have to plot. So we're going to do one of these. It's our last one, and it's got transformations using e. So again, I want you to take a second. I want you to enter that in the calculator. I want you to get a table and put it on the graph, and then we will join each other to make sure we get the information correct. Pause now. Okay, so as you saw on your own graphing calculator, the values again were not really pretty, and that's really because we're using a base that's not really pretty. So I needed to find a string of numbers that felt acceptable and easy enough to plot, that they were going to fit. So I chose -4 through -1 as my x values. Once I tried to use 0, 0 was 18. It wasn't going to fit on approximately 18. It wasn't going to fit on my graph. So I didn't get to use it. It doesn't mean I can't find my y-intercept. It just means I didn't graph it because it didn't really fit on this. Now I could scale, which is another option, but I seem to get enough of the shape of this graph. So my domain is all real numbers. My asymptote is at y equals -2, and that's because I shifted down to -2, which means my range goes from -2 to infinity. And my y-intercept, I'm going to have to use the table in the calculator because I didn't actually plot it this time. So it's 0, 18.086, and that's enough. That's what the calculator shows. So you can see that using a base of e doesn't always produce the nicest graphs, but it doesn't mean we can't graph them, and we can't graph them, as accurately as possible. So it's never just a sketch. I'm always using ordered pairs that I got from my calculator. All right, you guys, go back and make any notes or any comments of where you need some extra practice, and we will make sure that we get to that when we're together next.